Welcome to Algebra 2 CST release question number 4. It says, what is the solution to the system of equations shown below? So this one, initially, I admit this looks kind of nasty at first. But we've got three variables here, three equations, three unknown variables. But we just need to take things, the way to attack this is to take two equations at a time, try to get rid of one of the variables, and see where we can go from there. So there may be some shortcuts sometimes that will work out, but let's just tackle it two equations at a time. So let's take a look at these two first and see if I can get rid of some of the variables here by potentially multiplying both parts by something. So this top equation, I'm going to try to get rid of the z's first of all here. So the top equation, let's do that. So no change here. I'm going to write no change right there. I want to get rid of the z's. If this was 3z and this was negative 3z, they'd cancel. And so I'm going to multiply everything down here times 3, positive 3. So this one I've got 2x minus y plus 3z is equal to 8. And down here I'm going to have 3x, and this times that will be negative 18y, and this would be negative 3z. So we have that would equal 0 times anything is still going to be 0. And so with that gets rid of the z's, and I have 5x minus 19y equals 8. So I'm getting closer, I'm getting warmer here, but still I need to get rid of the x's or the y's. I just need one variable, or I have to get one variable in the end. So let's try to take these two now. Why don't I use a different color to make things stand out a little better? So now I'll use green. I'm going to take these two equations and I'm going to do the same sort of thing. So I want to take this top equation here and this bottom equation here and see what happens. So I'll segregate those like that. So let's take this top one, and I'm trying to get rid of the z's again because I want to be comparing x's and y's only here and down here. So to get rid of the z's, looks like I could multiply by negative 9 here. That would make that a positive 9z, which would cancel with the negative 9z. So I'm going to say times negative 9, and then this one I'm not going to change. No change on this one. And so let's multiply everything by negative 9, and that would give me negative 9x plus 54y plus 9z equals 0. And this one no change, so just rewrite it just like it is. Got that, and then combining those equations together, a linear combination, gives me that this cancels out with this. Why this works is that if I'm adding things that are equal to things that are also equal, when I put them together, kind of like I do on a scale, if you add two things that are equal or a balance that you might see, I'll just draw a quick picture. If you see something like this in a science class, if you got things that are equal weights here, and then you add two other things that are equal weights to it here and here, they're still going to balance out. The same idea works with the equations. These things are still going to be equal after you add equal things together. And so this right here canceled. This would be negative 15x. And this would be pretty large here, but we've got 57y. That would equal 0. So from there, now I'm going to take a look at these two equations, this one, and combine those together. So I've got this right here. I'm going to go with blue now, just to keep things easier to follow. I'm going to take this one, and I'm going to take this one, and use linear combination one more time to solve for, it looks like I'm going to solve for y. I can multiply this by 3, and then that would cancel out with the x down there. So let's do that, times 3. This one, no change. If I do that, I'm going to have negative or positive 15x. This would be minus 57y equals, this would be 24. And then down here, negative 15x plus 57y is equal to, this is still going to be a 0. And so if we do this, we notice something very interesting here. This is going to cancel this with this here and here, and then these happen to be the same as well. So if I would have multiplied this times Well, it actually is the same number, times 3. That cancels out there and there. So I'm going to get 0 equals, put those two things together, 24. So when you come to something like this, you should ask yourself, what's going on with that? Is that ever true, that 0 equals 24? Can that possibly be true? If you say no, you are correct. So this is never true. So think of it like this. This is never true. So is there going to be a possible solution, something that will make this a true set or system of inequality, or of equations? Sorry. Will there be something that makes it a true system of equations? No. You can't make it. It's not possible because you have this inconsistency, or this thing that will never work out here. So you have never true, so there are going to be no solutions. So from there, I can just look at my answers and say choice C has got to be the right answer.